population genetics and how to use the Hardy Weinberg equation. The Hardy Weinberg principle states that the alleles and genotypes will remain the same or constant from generation to generation. So just to remind you, genotype is the genetic makeup, like big B or small b, and the phenotype are the physical features, what it looks like, e.g. brown hair or blonde hair. Another term, allele. So allele stands for different forms of the same gene. So for example, big N or little n. So big N would be dominant, small n would be recessive. Heterozygous, the dominant and recessive alleles are together. So for example, big N, small n. So the dominant characteristic would be seen. And then homozygous, both alleles are the same. So this could be either two dominant alleles present or two recessive alleles present. Remember, they always come in pairs in the genotype. So there are 5 assumptions that are made for the Hardy Weinberg principle. Random mating, a large population, no natural selection, no mutation, no migration. So in using the Hardy Weinberg equation, we use the small letter P for the dominant allele and the small letter Q to represent the recessive allele. All the alleles in a population will add up to 100% or 1. So P plus Q is equal to 1. In a population, they will be either homozygous dominant, heterozygous, or homozygous recessive. So to put it into our Hardy Weinberg equation, P squared plus 2PQ plus Q squared is equal to 1. Because if you remember, P stands for the dominant allele, small b stands for the recessive allele, and the P squared plus 2PQ plus Q squared being equal to 1 is the frequency of the genotypes. When looking at the question, there's 2 things you must identify first of all. Is the question about the alleles or the genotypes? If it is about the alleles, then you're using the letters P and Q. If they've talked about their features, then you're thinking about their genotype, so you're using your P squared, 2PQ and Q squared. Then you need to identify which is the recessive trait. So in this example, we're looking at pigs. So we're using the letter big B for the dark pigs and small b for the recessive pink pigs. So we have 6 pink pigs and 9 dark pigs. What is the frequency of each allele? We have 9 dark pigs, and they could either be homozygous dominant, big B, or heterozygous, big B, small b. We have 6 pink pigs, so they are the recessive trait. So they can only be small b, homozygous recessive. Altogether, the population is 15 pigs. So because we know BB is the recessive, we then know from the Hardy Weinberg equation that that is Q squared. So 6 out of 15. Q squared is equal to 0.40. So we can then work out the allele frequency of the recessive allele Q by square rooting 0.40 and getting 0.63. From that, we can then work out the frequency of the dominant allele by P plus Q equals 1. So P is the dominant allele, so P is equal to 1 minus 0.63, which gives us P being worth 0.37. Once we know the allele frequency, we can then work out the genotype frequency, so how many pigs have each trait. So how many are homozygous dominant, P squared, heterozygous 2PQ, or homozygous Q squared. So P squared plus 2PQ plus Q squared is equal to 1 when we put the information into the equation. So when we do our calculations, p squared then will equal to 0.14, 2pq 0.47, and our q squared 0.4. This information tells us the genotype frequency. So for example, q squared is 0.4, or 40% of the population is homozygous recessive. 47%, or 0.47 of the population is heterozygous, and 14% is homozygous dominant. And we are assuming the 5 conditions of Hardy Weinberg's principle are being kept. From this, you could then work out the number in the population that will have a particular genetic makeup, how many would be homozygous dominant or how many would be heterozygous. So for example, if a population of 250 pigs, how many of them are heterozygous? So we know 2pq from our earlier calculation is 0.47. So 40% of the population is heterozygous, so 47% of 250 pigs is 117.5, so we'd say 118 pigs.